This is part 2, the derivative of the inverse of a function indirectly. These are just going to be some examples. So, using the definition of inverses, as long as we're doing f and g, this could work for, f and h or whatever. But it's easiest to see with f and g instead of maybe f and inverse f. But so the derivative on the left of f and of g of x equals x. That's pretty straightforward using the chain rule. So the derivative of f is f prime, still with that same input g, chain rule times g prime, and the derivative of x is 1. On the right-hand side, we get basically the same idea, just, the composition is in the other order. So we do the derivative of this outer g prime, still has f as the input, and then chain rule, the derivative of f is f prime, so we multiply there, and the derivative of x is 1. Ideally, you can use just logic in a problem where you need to find the derivative of a function indirectly, but if you're an algebra person and sometimes they get a little bit confusing, so you need to use algebra, this is what you would use. And I'm trying to show you that it's actually not going to matter which thing you need. So here we can directly write g prime of x is 1 over f prime of g. But if you had done this derivative, as in the derivative of f of g, instead of the derivative of g of f, if we needed f prime, we could have kept f prime of g of x and divided both sides by g of x. And we just have to do a little translation about, this x value in f is that y value in g and that sort of thing. Okay. Anyway, so over here on the right-hand side in blue, there we go. If we want g prime there, notice we can get a different version of g prime, but it actually has the same idea. So what's common between these two? Well, g prime of something on the left, and on the right, what we have is the reciprocal slope of f somewhere else. And we sort of have the same relationship. So g prime of this y value that comes out of f is going to be equal to 1 over f of, the x that creates this y value in f, or something like that. It'll make more sense, hopefully. If it doesn't, I have a feeling it doesn't, when we do an example here in a moment. So g prime of some x value is the reciprocal slope for f, not at the x value in g, but, the y value that gets spit out of g. That's what we put into f. Okay, so this is the best way my brain works. The derivative of the inverse at c is the reciprocal of the derivative of the original function at the corresponding x, which is going to be f of c, because the x in the inverse is the y in the original function, or the x in the original function is the corresponding y in the inverse, right? So let's say here, the derivative of the inverse of f at, let's say, c equals 2, right, is the reciprocal slope of f at 1, but at what x value over here on the inverse? Well, it's this y value of 2. Okay, well, let's just do an example, and hopefully this text kind of looks like it came out of the AP test, and it did. I cut off the multiple choice answers. It's either 2009 or 2013. So let f be the function defined by f of x is x cubed plus x. If g of f of x equals x, and that is also equal to f of g of x, and g of 2 is 1, what's the value of g prime of 2? It doesn't say this in words, but it says it in idea. This stuff right here, that just says f and g are inverses. So the other thing, once we know f and g are inverses, we need to have some ordered pairs. And it tells us, well, we're going to be talking about g prime of 2, and we actually don't care exactly what g of 2 is, but it's good to know because you'll see in a moment we're using f. Anyways, so g of 2 is 1, and if f and g are inverses, we can swap the input and output. That means f of 1 is 2. Okay, so we're going to start off with this definition, and you only have to use half here. G of f of x is equal to x, and you notice that was kind of given up top. And we're going to find the derivative, like I just showed you, g prime of f of x times f prime of x is equal to 1. And we're looking for g prime of 2, so we're going to isolate the part with g prime. And we're just dividing both sides by f. All right? And you kind of have to think a step ahead here. So let's go back before there. We want to have a 2. I don't know why this is drawing so poorly, but whatever. Okay, so we want to have a 2 right here as the input to g prime. And this says f is in there. So we need a y value of f that's equal to 2. So we need to substitute. We already did that logic up here. F of 1 is 2. So we want to put f of 1 in here so that we end up with g prime of 2. So g prime of 2 is 1 over f prime of 1. Option 1. If you start out thinking, well, I need g prime, this is actually the easier version. F of g of x is equal to x. We're still going to do the derivative using the chain rule. F prime of g, chain rule, times g prime. Derivative of x is 1. And we still want to isolate the g prime part. So g prime of x is 1 over f prime of g of x. And the reason this is a little bit easier is we want g prime of 2. We just put 2 into this x and 2 into this x inside of g. So then we really can't evaluate, or at least easily, f prime of g of 2. What's g of 2? Oh yeah, we already did that logic back here. G of 2 is 1. And you can kind of also see that the problem is set up to do it this way. They're kind of giving you the easy version. G of 2 is 1. You're looking for g prime. So if you thought ahead, it might be easier. I don't think we're there yet. Anyways, so how the heck do we finish? We need f prime of 1. Well, that's actually easy, right? We have f of x up top, so we just need to do a pretty easy derivative of a polynomial, 3x squared plus 1. Put in, what did I put in 2? That was a mistake. I must have been doing that early in the morning. Okay, and then f prime of 2 is not 13. F prime of 2 is 4. So anyways, what that means is we can finish off here, and cross that off, that's 4 too. Right, we would just replace f prime of 1 with 4. I hope the next slide's not that bad. All right, example 2. You can see pretty similar thing. F is differentiable, so f has a derivative. F of 3 is 5, f of 6 is negative 4, f prime of 3 is negative 2, and f prime of 6 is 2. The function g is differentiable, and this tells us, again, a different way of saying that f and g are inverses. G is the inverse of f for all x. So what is the value of g prime of 5? So I guess the first thing to do, like I said, make sure that you know g is the inverse of f. You don't have to write that. And we're talking about g prime of 5. So where the heck is that? And the answer is right here. Remember, if g and f are inverses, then this 5 is an x value in g, and that 5 is a y value in f. Right? So we actually don't really care about f of 6 is negative 4. That's just there to confuse us. So, you know, ideally, again, if you knew and it's multiple choice, no big deal. The derivative of g and the derivative of f are going to be reciprocals, just not at the same x value, at the corresponding x value. So g prime of 5 is going to be the reciprocal slope of f at 3. And so we could just jump there. That'd be the easy way. But if this was your first problem, or it came up in a warm-up or a test or something like that, okay, we'll do the algebra. And thinking ahead, if we want g prime, this chain rule, we're going to get g prime most easily by having g as the input. So derivative of f is f prime, still of g of x, times g prime. Derivative of x is still 1. And so g prime is, again, reciprocal of f prime of something. And if we put a 5 into g prime, we have to put a 5 into g, and we end up with this idea that I started with. If you understand, derivatives of inverses are going to be reciprocals, but not at the same x value, at that corresponding x value. We end up with this g prime of 5 is 1 over f prime of 3, but we could kind of memorize and start there. I think this is the last one. So we get multiple choice here, which is kind of nice, and you can tell this is definitely not recent since it still has 5 answer choices. So f is a differentiable function. F of 3 is 15. And, you know, thinking ahead, it's obviously an inverse derivative problem, but there's going to be a hint in here. F of 6 is 3. F prime of 3 is negative 8. F prime of 6 is negative 2. The function g is differentiable, and g is the inverse of f. So if you know g is the inverse of f, then f of 3 equals 15, which means g of 15 is 3. F of 6 is 3, which means g of 3 is 6. And I guess the translation to the derivatives is a little harder because we have to do flip-flop inputs and outputs. Anyways, so I guess the first thing we would think, oh man, I put everything all together and didn't animate. Okay, so g prime of 3, and I'm thinking g of 3 is 6 because f of 6 is 3. This one's here to confuse me. And by the way, that means this one is here to confuse me as well. So ideally, you would just think, hey, g prime of 3 is going to be the reciprocal slope of f at this 6. If you want to do the algebra, I'll leave that to you. But the algebra, in every case, if you need to do it, is going to be either f of g of x is equal to x, do the chain rule derivative. Or like way back here, you could have done f of g of x. Either one works. Okay, so that's all I have. Oh, apparently not. I put that in here.